This is part 4 of section 1.1 in the intermediate algebra. This time we're solving an equation that starts off with fractions. There are a couple of ways you could work these. You can keep the fractions in there. Right here we have like terms, so if I want to use the fractions on my calculator, I could do 3/4, move outside, minus 1/3, and then hit enter, and it will tell me it's 5/12. And then I could just use my calculator and deal with the fractions and move things back and forth until I got my answer. That's a perfectly legitimate way to work this. However, most people don't like that very much. So what we can do is we're allowed to multiply both sides of the equation by any number other than 0. And if we pick our number correctly, we can make sure every one of these fractions goes away. Now what you want to do is you want to figure out what the least common denominator would be for every fraction you have in your equation. So I have a 4, 3, 6, technically a 1. In this case, with 4, 3, and 6, our LCD is 12. 12, okay? So what I'm going to do is I'm going to multiply each and every single thing in here by a 12. Including this that doesn't have a fraction. So what I'm going to do is I'm going to write 12, and by a fraction I'm going to write it as 12 over 1, just so it's easier to see what's going on, times the 3/4 x minus 12 over 1 times 1/3 x okay, and this is equal to 12 over 1 times 5/6 x minus, it's going to be, you can write it as 12 over 1, which is the same thing as just 12 times 5. Okay, now what should happen is on each of these, if you multiply, if you do a cross cancellation with the fractions, remember you can, when you're multiplying fractions, and this only works for fractions, you can multiply straight across. So 12 times 3 would be 36 over the 4. Or you can cross cancel. The 12 and the 4 are both divisible by 4. If I divide that by 4, I get a 1. Divide this by 4, I get a 3. 3 times 3 is 9, so that is the same thing as 9x. 36 divided by 4 is also 9x, so you get the same thing there. Minus. Now the 3 and the 12 should reduce. Divide this by 3, you get a 1. Divide this by 3, you get a 4. 4 times 1 is 4, so this is 4x, equal to. The 6 and the 12 reduce. Divide this by 6 to get a 1. Divide this by 6 to get a 2. 2 times 5 is 10. That is 10x. If you have found the correct least common denominator, every single one of your fractions should go away. Don't forget to multiply this part. 12 times 5 is 60, so this is minus 60. Now let's just move things around here. I have 9x minus 4. That's those are like terms. If I just combine those, I get 5x is equal to 10x minus 60. Now let's move things around. Since I don't have another constant here, it is legal to move this over to here and then this over to here, but it's a lot of work that way. You could just move this over to here and avoid all of it. So I'm subtracting 10x from both sides. 5x minus 10x would be negative 5x is equal to, that's supposed to be 60 there, equal to negative 60. Now divide both sides by a negative 5. And we get that x equals 12. Now, do we always get our least common denominator back? Absolutely not. It just happened in this case. I could take the 12, put it in the memory of my calculator, use the fraction button. I would enter 3/4, move off to the side, plug in our x, and you should get the same value on both sides. Okay. So let's look at another one that involves fractions, but it is a little bit more difficult. Okay. So in this case, I don't have just a single numerator. I have a complicated numerator in each of these. Now again, I can follow my fraction rules. I can get common denominators, combine these together, do all that kind of stuff. Or I can multiply everything by the least common denominator and cancel everything out. It works the same way even though this looks uglier. My denominators are a 5 and a 2. So my least common denominator would be a 10. My LCD is equal to 10. So I'm going to multiply each of these fractions by a 10. Okay, so this is 10 over 1 times 2x plus 5 over 5. And that equals to 10 over 1 times 3x plus 1 over 2 plus 10 over 1 times negative x plus 7 over 2. Now, just like in the other problem, every one of these denominators should cancel out. Okay? The 5 and the 10 reduces to a 2. Divide that by 5, that's a 1. That becomes a 2. Now, this should be 2 times all of this. That's what's a little bit different from the previous problem. In the previous problem, we had a simple number up here, and it was a simple multiplication. But here, we're going to have to distribute. So this is 2 times 2x plus 5 equal to. The same thing happens here. 2 and the 10 reduce. Divide that by 2, it's a 1. Divide here, it's a 5. These are the same values, so that's also a 5. So I need to distribute 5 times 3x plus 1, and then again 5 times negative x plus 7. So our fractions are gone. Now let's distribute here, here, and here. That gives me 2 times 2x is 4x plus 10 equal to 15x plus 5 plus 5 times negative x is going to be negative 5x. I could have written minus 5x here. 5 times 7 is 35. Now this side is already as simple as it can get, but on the right I need to combine like terms. I have 15x minus 5x, which gives me 10x. And then 5 plus 35 gives me 40. Okay, so now I need to move the 4x or the 10x. I'm choosing to move the 4x over to here. So I subtract 4x from both sides. I got 10 is equal to 6x plus 40. Now let's subtract 40 from both sides. That gives me negative 30 is equal to 6x. Divide both sides by a 6. And I ran out of room here, but that gives me negative 5 is equal to x. I can take negative 5, plug it in up here, do the arithmetic, and it should check out.